I do appreciate the opportunity to kind of tell you some of the highlights of the sort of developing story that we're getting out of this long-term data set on desert rodents at the LTR. Before I get started, though, I want to thank some folks, in particular the field crew, who's actually the ones that go out every fall and do the rodent trapping. And so the kind of continued effort of those guys is really what's kind of produced this nice long-term data set. I'm going to present data for 11 consecutive years. We're actually up to 13 years now and counting. And so it's a good data set. Okay, when I give this talk or some version of this other places, I usually talk a while about the landscape change, shifts from grasslands to shrublands and all the drivers. I think with this group, I don't need to kind of dwell on that. In fact, you've probably seen this graph or some version of it from Deb or someone else 100 times by now. So we won't dwell on that. But the question is, when you have this dramatic landscape change, right, it really changes the habitat structure, the floristics and the structure. You know, what effect does it have on wildlife? And in particular, are there negative consequences for biodiversity when you get these state transitions from grasslands to shrublands? And we can look at sort of a broader view of this by looking at this meta-analysis that was published a few years ago by Dave Eldridge. And among the variables they looked at were two for richness for two groups, vertebrates and ants. And in terms of across the board, there wasn't any consistent negative effect of shrub encroachment on these groups. Okay? And so the particulars of the situation might matter. I will point out that this review and most studies have looked at richness or diversity and asked whether richness or diversity is affected by shrub encroachment. What about something like rodent biomass instead of diversity? Well, one framework we can look at to think about that is this idea of energetic compensation in zero-sum dynamics, which is the idea that if you have interacting species and they have some compensatory dynamics, okay, that something like total biomass might still stay relatively stable, okay? So the idea is, okay, maybe shrub encroachment reduces some species. If you have a compensatory positive response for other species, you could end up with a balanced biomass. Now, if these interacting species differ in body size, then you might have to get some kind of compensatory response and abundance to balance that biomass ledger. But this is really the key predictor that when you're looking at environmental change, something like biomass might be more stable than something like species composition, which is going to bounce around more. And that would support this idea of zero-sum dynamics and energetic compensation. This idea has been supported by work over Portal, Arizona, in Chihuahuan Desert. But we don't really know if it generalizes because some recent work by Doug Kelt with small mammals down in Chile, in an arid system in Chile, found no support for energetic compensation. So we don't know if it's really a general pattern or not. Okay, and overlaid on this kind of spatial change in habitat, of course, there's a lot of variability in precipitation. We all know that in the desert. And so you get these periodic pulses of precipitation that can lead to pulses of plant productivity. And these bottom-up effects could have time lags, and they might also interact in some way with shrub encroachment. So there may be some interactions between bottom-up processes and shrub cover. Okay, so that leads to the two kind of main sets of questions I want to look at today. Does shrub encroachment lead to a degraded ecosystem, at least as looked at through the kind of the lens of rodent biomass? Or can we find some support for this idea of energetic compensation where we're not seeing major shifts in biomass despite other changes? And then do these bottom-up processes, these links between precipitation, productivity, and biomass, are they similar among ecological states, or do they change whenever you get change from grassland to shrubland communities? And also, do any of these things depend maybe on which functional groups of rodents that you look at? Okay. So here's the Ecotone Design. There's basically 3 spatial blocks. And each one, and the blocks are basically 3 pastures that you're probably familiar with, pasture 3, 9, and 12. That's where these are located. And each block has a rodent trapping grid in grassland, ecotone, and mesquite shrubland. So they represent gradients from black grama dominated to mesquite dominated. Okay. Again, we have 11 years of data, over 3,600 captures. Measure NPP on the rodent trapping grids, and then we have precipitation data kind of at the pasture scale. So I thought I should introduce the roster of players here, if you're not familiar with the Chihuahuan desert rodents. And I just want to say, first off, these are way cooler than the mammals we have in Illinois. They pretty much all look like this, different variations of that theme. So this is a much better place to work on mammals. The granivores include the larger kangaroo rats and then smaller pocket mice. And these guys all focus on eating seeds. These guys are herbivores too, the folivores, but they don't really specialize on seeds. That includes the Hispid Cotton Rat, and I'm going to tell a little story about them in a minute, and 2 species of wood rats. And then the omnivores are, here at least, are really dominated by a single species in terms of biomass, and that's the northern grasshopper mouse, who makes its living ripping heads off of arthropods. Most years, the biomass produced by the granivores and the folivores compared to the omnivores, it's about an order of magnitude more for these guys. So I'm going to focus on these top 2 groups and not talk too much more about the omnivores. Okay. So there's a lot on here, and I just want to point out just a couple patterns. These are rank abundance curves for each of the ecological states. So the most abundant species, in this case, Ord's kangaroo rat, is on the left to least abundant, and that's shown by these circles here. Okay, so most abundant to least abundant, and then the bars are the corresponding biomass produced by that species. Okay, so bars are biomass, and the other ones are rank abundance. I just want to make a point that there are some big changes with shrub encroachment. Okay. So this is the banner-tailed kangaroo rat, probably my favorite desert rodent. And the grassland habitat is 3rd most abundant, but it actually produces, over time, the most biomass at the site. So the most biomass produced in grasslands is by banner-tailed kangaroo rats. On the shrubland sites, they're more like about 7th or 8th in abundance, and they produce a lot less biomass. Okay. Now I'll show you just one pattern going in the opposite direction. This again is the Hispid Cotton Rat. They're near the bottom of the rank abundance curve on the grassland sites, and only have moderate biomass production. But they're the 4th most abundant on shrubland sites and have substantially more biomass production. Okay. So I just want to kind of give you a picture that there is a lot of changes in species contribution, or species composition, at least in terms of kind of the biomass contribution they make in these different habitats. But what we see is no strong effect of shrub cover on total biomass. So this is over the 11 years in the 3 ecological states. Strong effective year, but not really a strong effect of shrub cover at all. And in fact, the 2 years where there was a trend, 2007 and 2008, it was actually grassland sites lagging behind the shrubbier sites. All right, so no strong effective degradation kind of effect where you see a reduced biomass in the shrubbier sites, and more or less consistent responses across the states. And while I have this up there, I just want to also show you the precipitation data for the same time period. Summer precipitation is more important for these guys. This is the average. And so what you see in 2006 is way above average, but you don't see much response. Where you see the response is the following fall. You got a 1-year time lag. It's typical. 2008 above average rainfall, 2009 another peak, and they kind of went through a drought, kind of a dry period for a few years. 2013 slightly above average, and they responded the following fall. So 1-year lag to summer precipitation, and I'll kind of return to that in a second. What I want to go back to is this biomass and look at granivores versus folivores, those two. You see some similarities and some differences. One thing I want to point out is, like, even during these dry periods, you still have a fair amount of biomass produced by the granivores, right? Whereas the folivores pretty much just go down almost to nothing. Like they're down to virtually no contribution. And here's one of the kind of cool stories emerging, I think. A lot of this pattern is driven by transient dynamics of this species, the Hispid Cotton Rat, okay? Which in the southeastern US is really abundant and it's thought more of a grassland species. So it's acting a little bit different here, as I'll show you. First 3 years, virtually, when I showed up on one trapping grid, 1 year, virtually non-existent. Got the good rains in 2006, 2007, it's on nearly all the grids. It's everywhere and contributing a lot of biomass. It hangs around for 3 years, and then during the next dry period, disappears for 4 more years until we get the next good rain year. Then all of a sudden, again, it shows up on nearly all the sites. So that obviously begs the question is where the heck do they go during these dry periods? We started hypothesizing that it might be in playa habitats, low-lying areas that have a little bit more moisture. And then I found a nice gem, a paper that Walt Whitford published 40 years ago now, back in 1976, where he trapped the one playa habitat and one upland shrubland habitat. And he only found Hispid cotton rats in the playa habitats. He didn't see the movement back and forth, but it did at least substantiate that at times they use playa habitat. So I kind of followed it up and said, well, if playa habitat's important, then we ought to see some effect of connectivity to playas on these guys. And that's some analysis I just did recently. So what this connectivity is, if it's a high number, it means that these rodent trapping grids have a lot of playas nearby and or large playas. So it weights distance to playas and their size. It's like a connectivity metric in metapopulations, if anybody knows about that. And surprisingly, just that measure and shrub cover explain nearly all the variation in the numbers of Hispid cotton rats that we see on site. This is over time. And to give you an idea what this looks at like out on the real landscape, just kind of captured this. I don't know how well you can see it from Google Earth. These are the 3 trapping grids in pasture 12. They represent these 3 points here. And these are the playas and their watersheds. So you can see a lot of playas in that area. These are fortunately, these are all mapped out by Owen McKenna as part of his graduate research. So there's 30 playas on Jornada, and they're all mapped out, so I was able to take advantage of that. So this is kind of a cool result. We want to follow this up perhaps in the future and get a little better idea about what's going on in terms of their movements. First, verify that this is their refuge during drought. Get a better idea of their movement, and also try to get a sense if there's any kind of source sink dynamics going on. A lot on here, and I'm just going to make 1 or 2 points based on the color coding, so you don't have to take too much in here. Core species are species that are on a particular ecological state more than half the years. So if they're there more than half the years, they occurred more than half the years during the study, I'm going to call them a core species. Okay. And you can see most of granivores are core species. And core species should respond strongest to local habitat conditions. Okay. The folivores, we've got 1 core wood rat, we've got 1 I'm calling an internal transient. And what internal transient means is that they're a core in one of the or more of the habitats, but not in that particular habitat. So they show up in ecotone and shrubland more than half the years, but not in grassland. Okay. External transient, that's our cotton rat. It's not a core species in any of the habitat. I kind of showed you it comes and goes. Okay, so the folivores have a mix of have more transients, and transients should respond more to kind of landscape heterogeneity as opposed to local habitat conditions. So keep that in mind. We're going to kind of look now, just the last part here, looking at the bottom-up effects in rainfall pulses. So first of all, that first link between precipitation and MPP in our data set, both winter and summer precipitation are important predictors of total MPP. And kind of surprisingly, total MPP was a much better predictor, I'll show you in a second, than production of annual grasses and forbs. We actually thought production of annual grass and forbs might be more related to seed production, but total MPP came out the strongest. So what I did, I set up a bunch of different models that I compared a relative support for. And what you can see is by far all the support was for total MPP as opposed to summer precipitation. So having that extra measurement, that extra link in the pathway was important. It told us a lot more than just summer precipitation for these granivores that are mostly core species, but again with a 1-year lag. So NPP this summer would predict biomass of granivores in fall of 2008. Set up the exact same model, it's asked the same question for the folivores. Got a completely different answer. Now nearly all the support is not for total MPP, but is for lagged summer precipitation. Okay. And there's also an interaction with shrub cover, positive interaction, so stronger responses on the shrubbier sites during the wet years. And so our interpretation of this is, again, these guys are driven a lot by the transient cotton rats. So they're not responding to the MPP on a particular site, the local conditions. It's just the fact that it's a good wet year. They're probably producing a lot in their source habitat, maybe the playas, and then spreading out across the landscape. And when they do, they're showing habitat selection. They're preferring these shrubbier sites. So they're responding more to the broader kind of landscape heterogeneity and not so much to local conditions measured by NPP on the grids themselves. Okay, so this is kind of the working model of what we think is going on for the bottom-up processes. Total MPP driven by summer and winter precipitation, 1-year lag affecting the granivore biomass. Something different going on with the folivores. Clearly NPP in general has got to be important. I put that in with a dotted line. But the strongest pathway we see is actually summer precipitation mediated by shrub cover. So we don't really see any kind of evidence for degradation when viewed in terms of total rodent biomass. Shrub encroachment doesn't reduce rodent biomass despite big changes in species composition. And at least in a broad sense, I think this supports the idea of energetic composition or compensation in the zero-sum model. But we want to dig into that a little bit more deeply and do some specific tests. These bottom-up processes linking rainfall to plant productivity to rodent biomass seem to differ between trophic groups, between the granivores and the folivores. And then finally, if we do actually get more drought frequency, and there's some uncertainty about the model predictions, but some models predict increased drought frequency in the Southwest due to climate change, these kind of core-transient dynamics are going to possibly get altered, and trying to understand drought refugia and this connectivity is going to become even more important.